Hello, so today we will talk about some basic geometric concept and figure. First of all, what is a coordinate plane? They also call plane. So plane is a flat surface that continues forever in every direction. It has two dimensions, length and width. So usually when it comes to coordinate plane, we will draw it like that. I'm sorry, it should be perpendicular. We have y and x. This is a coordinate plane. And then on a plane, the most basic geometric idea is point, which has no dimensions. A point is just a location of the plane, such as point A, B, C, D. And then 2 points, we can form a line. So what does line look like? So a line is look like this one. So a line is a one-dimensional figure that's made of an alternate number of individual points. So that means in here you have multiple points, they form together to form a line. So below is a line AB. In the geometric notation, we draw it as AB with the arrow on top, with 2 arrows. That indicated that the line keeps going forever in these 2 dimensions. And also sometimes you will see they say line AB in that way, without the line on top, without the arrow line on top. That also means indicate that's a line. For example, in here, a line would be what? A line CF. You can either write it in this way or just write it as CF. Also, you can also say, hey, this is 9FC. But in customary, we usually just name these 2 points in alphabetical order. So we more usually go by 9CF in these 2 ways. Okay. So what is ray? Ray is something that look like this one. A ray has one endpoint and goes forever in one direction. So for line doesn't have endpoints. And then it goes forever in 2 directions. Goes on forever in 2 directions. Whereas ray goes on forever in 1 direction. It has one endpoint. So in this case, we call it ray EF with a line on top and 1 arrow. That indicates that, hey, which have one endpoint and then goes to 1 direction forever. Usually we're starting with the endpoint E and then to the continue through F. So that's why we write it as ray EF. We don't write it as ray FE. No, for this specific example, we don't do that. And then the next one would be segment. What is line segment? Line segment is the section between any 2 points on the line called a line segment. The line segment have 2 endpoints. It doesn't go on forever because it has endpoint. And then they use the notation with 1 line on top of the alphabet with the 2 endpoints. So now let's recap. So for a line, I'm going to write it here. For a line, we will have notation like 9AB with 2 arrows because you know that it goes on forever in 2 directions. Or sometimes you can just write as 9AB. For ray, we have starting with endpoint and go through B. So this is ray with 1 arrow on top. And segment is that without any arrows. Okay, so now identify each 9 and 9 segment in this picture below. So in here, DF, this doesn't have arrow, right? So that means this is a segment, DF. And then now look at this one, is what? With 2 arrows, so this is a 9. 9, C, E. With 2 arrow, or you can write as CE, 9 CE. And then there's another one, BC, which is from B to C. With 2 arrow because it goes on forever in 2 directions. Or you can write in this way, either way. Okay, A is not a line or segment, it's just a point. Okay, so for this one, identify each point and the ray in the picture below. So what are points? You totally have 4 points on this picture. A, B, C, D. And then ray is similar to 9, but it has 1 endpoint and it goes in one direction forever. Goes on forever in one direction. So which means BC is our segment, and we use this location. Okay. So next one is ankle. So what is ankle? So by the definition, 2 rays with a common endpoint make up an ankles. So what means ankle is made of 2 rays and with 1 common endpoint. And the common endpoint is called the vertex. So when we have a notation on the ankle, we usually go by an order: ray, the endpoint, vertex, and then another endpoints. So for example, in this one, you can say, hey, ankle A, B, C. We use this notation as ankle. Or you can do it the other way, which is ankle C, B, A. Either way, it works. These 2 are equivalent. Okay, so that means in here, we have ankle what? S, R, Q. Or you can either say it Q or S. As long as it's point, and then vertex, and then to another point, then that's the notation of an ankle. So you have a different type of ankle. We're going to introduce it later in the later context. I'm going to give another example, such as this one, also an ankle, but it's just an ankle with 180 degree. So this ankle is ankle endpoint X, common endpoint Y, Z, or you can do it Z, Y, X, either way. Point, vertex, point. Okay, so now I'm going to introduce you what is right angle, acute angle, and obtuse angle. So by definition, right angle is any degree that measures exactly 19 degrees. The measurement of a right angle is equals to 19 degrees. So such as in this example, this is going to be a right angle because the measurement of this angle is 19 degrees. And then acute angle is what? The angle, the measurement of the angle between 0 to 19 degrees, which is less than or smaller than a right angle, then we call acute angle, which is this one, angle LMN. Is in between 0 to 19 degrees. And then the next one is called obtuse angle, which is greater than a right angle, but it's less than a straight angle. which is the measurement should be in between 90 degree but not equal to 90 degree to 118 degree. This is called obtuse angle. And then the last one is called straight angle. Straight angle is equals to 118 degree. Okay, so label each of the angle below as acute, right, and obtuse angle. So this one with the right angle sign, we know that, hey, this is going to be our right angle. So for this one, angle DAB, endpoint, vertex, another endpoint, is a what? Since it's less than 19 degree, because you can tell 19 degrees in here, right? So it's less than a right angle. So that means this is a acute angle. So for angle TQS, if we draw a straight line perpendicular to QS, the ray QS, so we notice that, hey, this angle is greater than 19 degree, but less than a straight angle, which is 180 degree. So this is going to be a what? Obtuse angle. And for this one is another example of an acute angle. Okay. Okay, so for here, identify all the acute angles in the given image. Let's try this one. So again, what is acute angle? Acute angle is the angle that's smaller than right angle, which is smaller than 19 degree, less than 19 degree, not equal to. So we have what? We have this one, angle XAW. This one is a acute angle. Anything else? This one, right? Angle YAZ is also an acute angle. So what about XAY? Is this one an acute angle? No, because this one is greater than 90 degrees. So this one is not a acute angle. Okay, so how do we measure angles with a projector? I'm going to link another video because it will be easier to show how to do it now. I couldn't show it on my iPad or my tablet. So I'm going to link a video and teach you how to do measuring angles with a projector. Okay, so the next one I want to talk about the property of the angles, such as how to identify parallel and perpendicular lines, find measures of angles, and identify complementary and supplementary angle. So what's a parallel and perpendicular line? So parallel lines are two or more lines that never intersect. So there's two relationships. If on the same plane, if it's on the same plane, that's really important. If they're on a different plane, you can say this is perpendicular or parallel, but on the same plane, on the same coordinate plane. Parallel lines are two or more lines that never intersect. That means they don't have intersection. But for perpendicular lines, there are two lines that intersect at a 19 degree angles. So this is a perpendicular. So when it comes to parallel line, we use the notation. So these two lines, we know that for 9AB. Parallel, this is notation we use, 9CD. Or you can write AB parallel to CD. So on the graph, how do you represent these two lines as parallel? We use two arrows on these two lines that indicate, hey, these two lines are parallel to each other. So for perpendicular, we use the notation. This means perpendicular, such as this 9WX perpendicular to 9YZ. Okay, so here's an example. Identify the set of parallel line and the set of perpendicular line. So now let's take a look. Which one is perpendicular? So perpendicular one is not hard to find, right? So in here, you see that, hey, here forms a 19-degree, 2 9 forms a 19-degree angle. That means this 2 9 is going to be perpendicular. So this 2 9 will be 1 and 2. So we have 9, AB perpendicular to 9YZ. You need to use this notation. And then the second one is here, right? We see another right angle lower than that. So we know that, hey, 9AB also perpendicular to 9WX. Okay, parallel. So which 2 9 parallel to each other? So if they don't have, remember what's parallel? Parallel means 2 9, they never met. They never meet and they don't have intersection. So we can extend this line and see if they have any extensions. So for this one, if you extend it, you will find out, hey, 9AB and 9CD, they intercept. So that means 9AB and 9CD, they're not perpendicular. But YZ and WX seems they don't have intersection. So we enable this in here, shows that indicate that these two are parallel. So I can have 9YZ parallel to 9WX. Okay, so the next one is finding the angle measurement. Okay, so now it's the measurement, how to find the measurement of angle IJF. So IJF is here. What do we know? Oops, sorry. So IJF is this angle. We don't know what's the degree. So how do we do it? So now we know that, hey, at least from this graph on the rotation, we know that angle MJH equals to 19 degree. And then this part forms a straight angles. So that means angle MJI equals to 118 degree. So that tells you what? That tells you what this angled IJH equals to angle MJI subtract angled MJH. Okay, I'm going to demonstrate this again. So the whole right angle was formed by two small angles. One is the known one, which is 19 degree, and then the other one is the one that we don't know, but we're trying to find out the measurement of it, which is IJH. So now we know that, hey, the straight angle equals to 118 degree. And then we have a right angle, which is MJH, 19 degree. So that this one is equals to what? Another 19 degree. So after we found this one, we used a similar method, a whole right angle, which is angle HJF equals to two small angles, 1 and 2, the combination of two small angles, which is angle HJI plus angle IJF. So we know that HJF equals to 118 degree. And from what we did previously, we found out that angle IJH equals to 19 degree at IJF. So now we do some algebra. And then we found out that, hey, the measurement of angle IJF equals to 19 degree. Okay, so there's another example. So it didn't show on the graph. I'm going to draw it here. So here's a graph. There's two endpoints B and C. This is D and this is 135 degrees. Now they are asking you, hey, what's the angle of D? Let's say this is A, DAC. Find the measurement of DAC. So DAC is equal to what? So from the graph, you may see, hey, oops, the whole straight angle BAC was formed by two small angles. One is 135 degrees, the other one is here, which is DAC. So that we can say, hey, the angle DAC equals to the straight angle, which is BAC, subtract the smaller angle, which is BAD. So this is equals to a straight angle, which is 180 degrees, subtract 135 degrees. So this is equals to 65 degrees. No, 55. No, 45. 45 degrees, sorry about that. So this is a 45 degree angles. Okay, so the next part I want to talk about what is supplementary and complementary angle. So by definition, which is in here, so supplementary two angles that measures adds up 118 degrees is called supplementary angle. And two angle, the sum of the measurement is 19 degrees, that is called complementary angle. They don't need to be adjacent to each other, they can be separate, but as long as their sum or adds up the sum of their measurement equals to 180 degrees, we call it supplementary angle. Such as the most common one is something that we just see the straight angle and then formed by these two angles, 135 degrees and 45 degrees. These two adds up equals to 180 degrees, we call it supplementary angle. But sometimes you might see something like that. I need to make this bigger. This is 114 degrees and this is 14 degrees. So these two angles also is called supplementary angle. They don't need to be adjacent to each other. They don't need to share one ray. They can just share one endpoint. Or sometimes you will see on the plan, these two angles, they don't even share anything. They don't share endpoint, they don't share the vertex, they don't share a ray, but they're 20 degrees and 160 degrees, even though they're separate. These are still called a supplementary degree. So similar idea to the complementary angles. Complementary angle is the sum of these two angles equals to 19 degrees. Okay, so example in here. So if there's two lines with endpoint A, X, Y, Z, B, and then found and given angle AXY equals to 13 degrees. And now they want you to find the measurement of AXZ. AXZ, which is in here. This is unknown. So now you take a look. This image shows that two intersecting line AB and YZ. So that means the line YZ forms a what? A straight angle, right? So we can say, hey, the angle, the one that we're looking for, AXZ equals to one straight angle, angle YXZ, which is this one, subtract the small angle YXA, the measurement of the small one, So we have 118 subtract 13. So we got the angle AXZ equals to 150 degrees. Okay, let's do something that a little bit complicated, such as this one. So giving you the graph look like this. Okay, so they want you find the measurement of, oh, I should draw the graph here, I'm sorry. Okay, anyway, it's the same. This is corresponding to example 6.113. So they want you to find the measurement of CAD. So now they're giving you what? The measurement of CAB and the DAE. So the measurement of CAD is where? Is the middle angles, right? So this is the same, not just two angles can form a straight angle. These three angles actually form a straight angles. So we can say, hey, the measurement of angle BAE equals to is formed by three small angles, including a angle BAC plus a angle CAD plus the right angle, which is DAE. Okay, so we know that the angle BAE, which is 180 degrees, now we just use substitution. The angle BAC is 25 degrees, plus this is unknown that we're trying to find out, plus angle DAE, which is 75 degrees. So now you use some algebra. You subtract 25 and 75 on both sides so that we have 100 equals to the measurement of angle CAD.